Today we'll be learning about z-score percentiles. Our objective is that we will use desmos to determine probabilities and percentiles based on the normal curve. So let's review the normal curve. In the center of the normal curve is our mean, and each tick mark to the right is adding a standard deviation. And every tick mark to the left is subtracting a standard deviation from the mean. So, the lifespans of turtles in a particular zoo are normally distributed. That's just telling us that we can use the normal curve for this example. The average turtle lives 91 years, and the standard deviation is 21.4 years. Shade the regions under the curve for turtles living longer than 48.2 years. So let's do that part first. So the middle is our mean, which we know is 91. We're going to add 21.4 for each tick mark to the right. And then we're going to subtract 21.4 for each tick mark to the left. So if we want to shade the regions under the curve for turtles living longer than 48.2 years, I'm going to start down here at 48.2. And shade everything to the right of that. Going past the 55.2 all the way into the tail of the curve. So, approximately, what percentage of turtles live for longer than 48.2 years? This is where desmos comes in. So we're going to click the keyboard icon, pull up the keyboard. We're going to go to functions. We're going to go to our statistics tab. We're going to go to our distribution tab. And we're going to choose normal dist. Inside the normal dist, we are going to put the mean and then the standard deviation. So in our case, the mean is 91, comma, our standard deviation of 21.4. We want to check the box that says find cumulative probability. So I'm going to click this box, and then it's going to ask for a min and a max. Here, our minimum is going to be 48.2 because that's our lowest value, and we're going to leave the max as infinity. In Desmos, the maximum will automatically be infinity, so you don't need to type anything there. So we're going to put in our minimum, 48.2, and it gives us this decimal, and that's the probability. So 0.9772. We're going to multiply that by 100. And when we multiply by 100, we get that 97.72% of turtles will live longer than 48.2 years in that zoo. Suppose we look at the scores of one component of the SAT. If 45,000 students took the exam with a mean of 528 and a standard deviation of 87. How can we determine what percentile a student who scored a 680 read? So we're still going to use the same normal dist function in desmos. Percentile means the percent below. So basically we want to know what percentage of people scored below a 680, and that'll give us the percentile. So we're going to use normal dist again. This time our mean is 528 and our standard deviation is 87. Because we want to know below, our min is going to stay at negative infinity and our max is going to be 680. You don't have to try and type a negative infinity. We just delete it, it'll automatically put it at negative infinity, and our max is going to be 680. So 0.9597. We multiply that by 100. We get that it's 95.97%, or that would make them the 96th percentile. Percentiles are expressed as a whole number. What percent of students scored between a 480 and a 760? So, still using the normal dist function. Our mean and standard deviation didn't change. This time, though, we're given a minimum and a maximum. So our minimum will be 480, and our max will be 760. $760. So we get 0.7056. Multiply that by 100 to change it into a percent, and we get that 70.56% of students would score between 480 and 760. How many students, so now we want to know how many people instead of what percent, scored better than a 675? So we're going to start with our normal distribution. $528, 87. We want to know who did better than 765, so that's our minimum. Our maximum's infinity. So we get 0.0455. But we're not going to multiply by 100 this time. That was for percentage. This time we want to know how many students. Well, 45,000 students total took the exam. So we're going to multiply this by 45,000. That gives us 2,047.5, which would be approximately 248 students. Can't have half a student. And for our last example, we're going to go backwards. What score would be in the 68th percentile? So it's giving us the percent this time. We want to go back and find out what score that student would have scored. So in Desmos, we're going to type in D equals normal dist with our 528 and our 80. So D equals normal dist 528, comma. We're not going to check the find cumulative probability this time. We're going to go down to the next line. I'm going to go to my functions again, still in the distribution menu, and I'm going to choose inverse CDF. So if you look up here, before we were finding the CDF, inverse CDF is telling it to go backwards. So we're going to do D, comma, and then 0.68 because that is the decimal form of the percentage we were trying to get. So you click the keyboard icon, choose the functions button, the dist tab, and then inverse CDF. The first thing's always going to be the variable that you used up here, and then this is going to be the percentage as a decimal. So inverse CDF D, comma 0.68 for this one. And when we type that in, it gave us 568.687. Normally we could just leave the answer like that, but because we're dealing with SAT scores and SAT scores are given as whole numbers, we would say that it was a score of 569. That's all for today. Fill in the summary and we'll see you in class.